In the first riveting episode of this series, I gave you some background on the problem that I had with a turnout was in a difficult location and how I had come up with an idea for using a servo to control that turnout and drive that with an Arduino. And to mount the servo, I was going to go ahead and use a bracket that I designed and 3D printed. So in the first episode, we did that design, we printed the bracket, it actually worked out, a couple of minor issues, but the bracket seemed to work. And so in this episode, we're going to jump into the Arduino sketch and take a look at the actual prototype Arduino circuit that I built. I hope you guys will find this interesting. Okay, let's take a look at the Arduino code. And before we jump into the code, let's take a look at the schematic. It's a very simple schematic. We only have pins 9, 2, 7, and 8 connected from the Arduino to the outside world. The servo is controlled through pin 9. The push buttons, the buttons that you use to throw the turnout, are both connected to pin 2 in parallel. So either button being pushed will cause the turnout to throw. Pin 7 controls the one signal, and pin 8 controls the second signal. There are two signals, one on each side of the tunnel. One that indicates from the York Station side, if you're trying to come out of the station, it indicates whether the turnout is green, means it's aligned for you, red means it's against you. And on the opposite side, coming from the York side into the tunnel, a green signal indicates that you have the main line selected or the straight path selected. If it's yellow, it means that the turnout is to the diverging position, so it'll either go into the station or into the interchange yard or the industries there. Now jump into the code. Start off, we include the servo.h library that is part of the Arduino IDE, or can be installed from the Arduino IDE. It's a standard Arduino library. I do some definitions here. The min and max values are the min and max numbers the servo will throw to. The servo control pin is pin 9. We'll see that used here in a minute. The push button is input is on pin 2. The straight route LEDs are on pin 7, and the diverging route LEDs are on pin 8. And I've defined a couple of constants here for clockwise and counterclockwise rotation. Next, I create an instance of the servo object. I have a couple of global variables. One is curve position, which is the current position of the servo, and there's a direction boolean, which controls whether the next direction to move will be either counterclockwise or clockwise. In the setup loop, we set the servo control pin mode to output. We write that to a 0. I don't know if this was necessary. I then set up the pin modes for the button. Input is an input with pull-ups, and the LED control pins are outputs. I then write a 1 to the straight route LED, so we set the initial route as being straight, and we set the diverging LED to 0, so turn those off. I then attach the servo using the library, attach the servo to the servo control pin. I initialize the serial port so I could do some debugging as I was developing this. And then finally in the loop, I go ahead and move the servo to the max position, which sets it to the straight through position. Now looking at the main loop, the first thing that I do is I sit here and I wait until a button gets pressed. So it sits here just waiting for the button. Again, I have some serial print lines in here to do some debugging to watch what's happening. Once a button has been pressed, I check the direction. If direction equals 1, then we will call the move to function with the max value. Otherwise, we're going to call the move to function with the min value. If we go down to look at the move to function, move to receives the value of where it needs to go, the destination. Create some variables here to track position, start, end, and step. And so now I say if the destination is equal to min, so we're moving from the max to the min, then our start is max, our end is min, and we're going to step -1, so we're moving counterclockwise from the max to the min. Otherwise, if destination does not equal min, then our start must be min, and our end will be max, and our step is a +1. So this just sets up the start, end, and stepping for whichever direction we need the servo to move in. After we've got all of the position variables initialized, we go ahead and enter the loop. The loop is a for loop where we say the loop control variable POS is start out equaling start position. We run this loop until position, as long as position does not equal the end position, and for every iteration through the loop, we're going to add to position the value of step. So this will work either for going from min to max or max to min with using that negative step value. Then each iteration through the loop, we write the new position to the servo. I delay for 10 milliseconds, again, just to give a nice slow motion action to the point throw. And then we continue to loop all the way through until we've completed all the iterations, until we've completed the loop. Then we update the current position variable with the destination that we just went to, and then I toggle each of the LED control pins. So basically I swap both signals to show the opposite of what they were showing previously. And that's really all there is to it. It's a very simple sketch, a very simple application. And we're going to go over to the bench now, and I will show you it set up on a prototype on a breadboard with the servo, and we can see how it works. So stand by. Okay, so here we are on the bench. We've got the servo mounted in the bracket, and we've got the breadboard built up. Let's go ahead and flip the power on. Okay, so now we can see that we've thrown to the straight through position, which means this is the York yard side signal. So this indicates from the York side going towards the station that the turnout is thrown for the main line, for the continuous run option. And on the station side, which would be this signal here, it's set to red, indicating that the turnout is set against you. You cannot leave the station until you throw the turnout. I've got two different push buttons here. One would be mounted on the York side, station side. One would be mounted on the York yard side. And either one of them will cause the turnout to throw. So if I push one of these buttons, turnout throws and the signal throws. Push the other one, and again you can push, that was the debounce there kicking in. Push either one of them and it will throw it in both directions. And so that's it. Again, I have 4 connections from the Arduino to the breadboard, plus the power for the servo. Super simple, but I think it's going to work well. So all that's going to be left now, and then that will be in the next installment in this series, will be to actually mount this in position, connect it to the turnout, and hopefully have a functioning solution to my problem. Thanks for watching, really appreciate it, and we will see you in the next episode.